Hey guys, welcome back. We're now in quarter 2 and we are on day 17. We are just getting into X and Y intercepts, okay? So we're starting to get into our linear equations unit. What we did in the first quarter is really kind of a lot of pre-algebra concepts to get us ready for what we're doing in the second quarter, which is talking about linear equations, okay? And linear equations would be equations of lines. All right, so I'm going to start out just by doing drawing a graph here. So I have my coordinate plane. This is my x-axis, and this is my y-axis. Okay, if I draw a line, and I draw a line, there's a line. Okay, notice there's a point that I cross the x-axis. It would be right here. Okay, and that point is actually where my y value, my up-down, would be 0. Okay, so that's the x-intercept. Okay, now there's another point. Here it is. This is the y-intercept. That's where we cross the y-axis. Okay, and I can actually figure out both of those points, connect the dots, and make a line. Okay, and that's what we're going to be talking about today, talking about the x and the y-intercepts. We did a little bit of it last unit when we talked about the 0 of the function and f of 0. Okay, so we're going to kind of be adding on to that. So the x-intercept of a function is where the graph crosses the x-axis. To find the x-intercept of the function, we're going to find the value of x when y is equal to 0. Now remember, with an ordered pair, your x is first and then you have your y. That's an ordered pair. We can take that ordered pair and graph a point on the coordinate plane. Okay, the y-intercept of a function is where the graph crosses the y-axis. All right, and to find the y-intercept of the function, you find the value of y when x is equal to 0. So notice it's different. Okay, x-intercept, you let your y be 0. Y-intercept, you let your x be 0. Okay, now the x-intercept is also the same as finding the 0 of a function. Okay, finding the 0. All right, the 0 of a function, because we're setting the output, or the y value, to be 0. All right, so same as finding the 0. Now, to find the y-intercept, that's really the same as finding f of 0. Okay, because that means your input is 0 or your x is 0. Okay, so we're going to just do some examples right now. All right, so here we have our first equation. 2x plus y is equal to 28. Find the x and y intercept of the function. So our first step is to find the x-intercept. In my x-intercept, I just like to always do a let and say let y be 0. Okay, just to keep myself organized, because if I'm finding the x, my y is 0. All right, what does that mean? It means I simply plug in y equals 0 in the equation. So y is 0. So this would become 2x plus y, well, y is 0, equals 28. Or 2x equals 28, and I divide by 2, my x is 14. Okay, the final answer, the x-intercept, is the x is 14 and your y is 0. Remember, the x-intercept is an ordered pair, so don't forget about having that y value listed. All right, step 2, let's find the y-intercept. Finding the y-intercept, so my let says let my x be 0. My input is going to be 0. So again, I use this function up here, only now it's 2 times x, so 2 times 0 plus y is 28. 2 times 0 is 0, so I'm left with y is equal to 28. So my y value is 28, but my x is 0. So my ordered pair is 0, 28. Okay, notice what I don't do is combine these two into one ordered pair of 14, 28. That's a common mistake. Do not do that. They're two separate points. Okay? 14, 28 isn't even an ordered pair that's on the x or the y axis. So one of those has to be 0. Okay? So when we do it this way, we've got two separate points. All right, let's try another example. All right, so we've got 3x plus 2y equals 6. We're finding the x-intercept. Again, I keep myself organized. Let my y be 0. That means it's 3x plus 2 times, instead of y, I put 0. And then it becomes easy. 3x equals 6. I divide by 3. My x is 2. So my x-intercept is 2, 0. All right. To find the y-intercept, I let my x be 0, and I plug it in again to the original equation up here. So it's 3 times 0 plus 2y equals 6. 3 times 0 is just 0, so 2y is going to be equal to 6. We divide by 2, and our y is 3. That means our x is 0, our y is 3. There's our ordered pairs. Okay? So if you would like right now, if you're starting to get it, why don't you pause the video and try them yourself, and then you can play it, continue on and see how you did. Okay? So it says to find the x and the y-intercept. So my x, I let my y be 0, and then I like to organize myself 2 different ways. So I got x, let y 0, and my y, I let my x be 0. Okay, so now I'm going to plug it in. 4x minus 2 times 0 equals 20. So I'm left with 4x equals 20. And when I divide by 4, my x is 5. So my ordered pair is 5, 0. Okay, then I let my x be 0 to find the y-intercept. When I do that, I have 4 times 0 minus 2y equals 20. I'm left with negative 2y equals 20. And then when I divide by negative 2, my y is negative 10. So my ordered pair is 0, negative 10. Okay, we'll do the same thing with the next one. So for finding our x-intercept, we let our y be 0. Okay, and then our y-intercept, let's let our x be 0. Okay, if our y is 0, we end up with negative 3x plus 5 times 0 equals negative 15. So negative 3x is equal to negative 15. And then I divide by negative 3, my x is 5. Here's my x-intercept. My y-intercept, we let x be equal to 0, so negative 3 times 0 plus 5y is equal to negative 15. Negative 3 times 0 is 0, so I'm left with 5y equals negative 15. When I divide by 5, I get y is negative 3. My x is 0, my y is negative 3. Okay? All right, so let's look now at, go to the next, whoops, went too far. Let's try to graph them, okay? So now we're going to use this, okay, use the intercepts, and we're going to graph the equation. So again, we start out, we find the x and the y-intercepts of the function. So my x, I let y be 0. Okay, so I end up with negative 3x plus 9 times 0 equals negative 18. 9 times 0 is 0, so I'm left with negative 3x equals negative 18. And then I divide by negative 3. So my x is equal to 6. Okay, so that means my intercept is 6, 0. So let's plot that point. All right, so this is my x and this is my y. All right, I start at the origin and I count 6 to the right because it's positive. 1, 2, 3, 4, 5. Oops, I'm off the graph. That's okay. All right, 6, 0 would be right about here. Okay, so we found the x-intercept. Now we need to find the y-intercept. So let's let our x be 0. So negative 3 times 0 plus 9y is equal to negative 18. Okay, 9y equals negative 18. We divide by 9, and our y is equal to negative 2. So we've got 0 and a negative 2. Okay, there's our y-intercept. So I'm going to start here at 0, and then I'm going to go down 2. So my x is 0, but then my y is negative 2, so I go down 2. I've got my 2 points. Now this is important. We're making a line. We're going to connect the 2 points. We're going to go a little bit further, okay? And we're going to add arrows on either end because a line will continue on and on forever, okay? So there's our first line. All right, let's try another one. Okay, and if at any time you want to try it on your own, by all means, pause the video, try it, and then see how you did. All right, I'm going to go a little bit faster. My x, and I let my y be 0. Okay, 4x plus 0 equals 4. 4x is equal to 4. And I divide by 4. My x is 1. So there's my x-intercept. It's at 1, 0, right there. Okay, don't forget, this is your x-axis, this is your y. My y, I let my x be 0. So we're left with 4 times 0 plus y equals 4. 4 times 0 is just 0, so we're left with y is equal to 4. Ordered pair is 0, 4. So I'm not going to go left or right, but my vertical is 4, so I'm going to go 1, 2, 3, 4. There's my pairs. I'm going to connect them, go a little bit further, and add arrows. There's my graph. Okay, so we've got one final one, example number 7. All right. Oh, actually, we've got 2. It's going to be a little special case. All right, notice we do not have an x in this equation. Negative 4y equals 12. Well, what happens if I try to find the x-intercept? Well, I know I need to let my y be 0. Well, what happens there? I get negative 4 times 0 equals 12. 0 equals 12. Well, I know that's not true, so there is no x-intercept. Okay, that means it's never going to cross the x-axis. Okay, well, let's look at the y-intercept. Y-intercept, let's let our x be 0. Well, there is no x, so we're just left with negative 4y equals 12, and we can solve for it by dividing by negative 4, and our y is negative 3. All right, that means our y-intercept is 0, negative 3, which would be right here. All right, so what kind of line can we have with one point that we know never crosses the x-axis? It would actually be a horizontal line. Okay, if this line went on and on and on forever, it would never cross that x-axis. Okay, so if there is no x-intercept, okay, we know it's going to be a horizontal line. All right, and it's going to be a little bit different than number 8. Number 8, let's do our x-intercept. We let our y be 0. Well, there is no y, so we're left with 2x equals 8. And we divide by 2, our x is 4. Okay, so that means our x-intercept is at 4, 0. Let's draw 1, 2, 3, 4. All right, but now let's look at our y-intercept. We let our x be 0, and we're left with 2 times 0 equals 8, or 0 equals 8. That's a false statement, so there is no y-intercept. Okay, what does that mean? Well, this is the y-axis. This point, it's never going to cross, so that's going to be because it is a vertical line. Okay, that line goes on and forever. It's never going to cross the y-axis. Okay, so I want you to go ahead and work on the homework. The homework is 17B. Thank you. Bye.